Hello. In this portion of the video, I'm gonna show how to look at compound interest. When we ended the previous portion of this section, I talked a little bit about the difference between simple interest and compound interest, where you have that simple interest accumulates at a slower rate as opposed to compound interest because you're compounding the accumulated amount per compounding year. So Um, the way of which that we look at this is that essentially you have that if you take the principal amount and you have that you're just doing 1 plus r every year, so that's after the first year, and then you look at, okay, so that's the first year, and then you look at the second year. So in the second year, um, basically you have that you're going to take the accumulated amount after the second year, and you have that that's going to be equal to the principal amount, which is now 1 plus r, and this is going to be multiplied by this is going to be multiplied by 1 plus r, which is going to give you p times 1 plus r to the second. Now, basically, if I repeat that process, however many years that there are for the compound, I'm going to have that over time, that's going to give me the following: p times 1 plus r, but raised to the t, because you're determining what the compounded amount is by using the amount of years that it's going to be done. Now, interestingly enough, with compound interest, you have that this can be done more than once a year, basically. So, for instance, we have that we can actually compound multiple times per year. So, that could be annually, that could be semi annual, that could be quarterly, and then that could be monthly, and then that can be actually daily. Now, we do have that there's another form of compounding which deals with continuously. Now, continuously is actually a hypothetical situation of which that you have that what if it was compounded every single moment or every minute, every second, and so on. Now, one thing that you will have to note is that, when we say annual, we mean 1, 2 for semi-annual, 4 for quarterly, 12 for monthly. Now, for daily, it's either going to be 360 or 365, depending. Now, I'll talk about like continuously in a later portion of this video or section. So, what ends up happening with our equation is that the interest is compounded multiple times per year. So we have that that's going to be 1 plus I raised to the n. Now here, I is equal to r over m, and then n is equal to m times t. So we have that this right here is what we call the future value with compound interest. So we have that basically that the p is essentially the same thing. It's the principal the R is the same, it's still the rate of interest. The only other thing that you would need to know is essentially just that the I is the interest rate per period. And then you have that the M is the compounding period. Now the N is basically just the number. It's the number of times that you have that the amount is compounded. So with this, we can probably say, for example, that let's say that we know that you have $1,600 is the principal, and let's say that the this amount is compounded monthly at an interest rate of 4.2%, and that's going to be done for 7 years. And we just want to say find the interest Okay. Now, let's not get too caught up on like interest paid back, interest earned. So essentially we have that A is equal to P times 1 plus R over M raised to MT. So let's do this in a way that we can just plug in. So we have 1600 multiplied by 1 plus 0.042 divided by 12. But this is raised to the 12 times 7. Now, when you do this computation, you want to do it in a way that it makes sense or that it works out. So you have 1600 multiplied by 1 plus 0.042 divided by 12, close it, but you're going to raise this to the 7 times 12. Okay, so that gives you 2,145 and 75 cents. So you have 2,145 and 75 cents. Now, the question is asking for the accumulated interest. So that's going to be the accumulated minus the principal. So that's going to be 2,145.75 minus the 1,600. Now, when you do that subtraction, you're basically going to find that the interest that was paid back or earned is 545 and 75 cents. And this is over a 7-year period. That's monthly. Now, let's say that, for example, that we wanted to solve for the principal. So we know that A is equal to P times 1 plus I raised to the n. But if you want to solve for P, you simply just divide. So you have A divided by 1 plus I raised to the n, but that's really the same thing as A times 1 plus I raised to the negative n. So in this case, this is more or less a formula that computes the present value but with compound interest. So that just means that we happen to know how much was borrowed. So we'll just call this present value. And this will be with compound interest. Now, not much is changing in regard to what's given I, n, and so on. So let's say that, for example, that in this one, we'll just say that A is equal to 10,000. And then what we want to know, for example, is so this amount is to be paid back, and it's compounded quarterly. At an interest rate of 4.25%, and this is going to be for also 7 years. Okay, so we just want to find the principal. Okay, so here we just use that P is equal to 1 plus, A times 1 plus I raised to the negative n. So here we know that 10,000 is to be earned. 1 plus 0.0425 divided by, well, it's quarterly, so that's going to be 4, raised to the, okay, so you have negative 7, well, really it's negative 4, so negative 4 times 7. Now, this is going to give you the principal amount, so we know it's going to be approximate. So we have 10,000 multiplied by 1 plus 0.0425 divided by 4, and this is raised to the negative 4 times 7. So we just push enter, and it gives us 7,438 and 39 cents. Okay, so this amount is actually just the amount that was deposited or lent, whatever you want to say. But if you wanted to know the interest that was earned, all that you would need to do for this to find the interest is you again take the accumulated minus the principal, which in this case, if you go back and you take 10,000, because you know that that's how much was earned or paid back, whichever way that you want to look at it, and you just subtract the principal, you have that that's going to be 2,561 and 61 cents. So this is the amount that of interest that's paid back, and this is over a 7-year period. So you can see that this is actually not, it's almost half really, but not necessarily, because you would have to increase these amounts